5. Good. Okay, trig identities. Oh, what's the date? 11/21. 11/21. We're doing trig identities. And there is applications for this. Think for a minute if you're in a recording studio and think about sound waves. Okay? And I know when I was a kid, I remember going to AC/DC in the Tacoma Dome, and they were really bad. They were horrible. I mean, you couldn't even understand. They were off tune. They were too loud. The sound was terrible, but it was loud. It was fun. It was like your age, and so we had a blast. We didn't care how bad the music was. And then you listen to the records, and you're like, they cleaned it up. So what sound engineers do is they take this music, they can then apply equations, and actually they'll start to simplify out the equations to get rid of the noise. Does that make sense? So people actually do this kind of math. It's crazy. So let's talk about how we're going to do it. So before we do anything, so for those kids who were not here, these are the identities you need. Here's my Pythagorean identities. Okay, you're going to have to copy these down on your own time if you're not here. Okay, these are my odd even identities. Sine of negative theta is negative sine. Tangent of negative theta is equal to negative tangent. Cosine of negative theta is equal to a cosine of theta. Secant 1 over cosine. Cosecant 1 over sine. Tangent is sine over cosine. And cotangent is cosine over sine. Okay, so here's my key before I even start for everybody. If there's any squares in our problem, go to these. Does that make sense? Go to these. If not, try and change everything into sines and cosines. I'll say it again. Try and change everything into cosines. So, key, okay, try and make, if you can, sines and cosines. Or, if you got square terms, use your identities, okay? So, example 1. All right, if I take a look at this, cosine is just cosine, right? Bam, just cosine. But tangent, what do you know about tangent? What's tangent? Look at your notes. What does tangent equal? There you go. So I'm going to go cosine of theta plus a sine over a cosine, right? Times a sine. Okay, now it hasn't helped me much, has it? Okay, so all I did is I changed my tangent to sine over cosine, okay? Well, that hasn't helped me much, but let's see. That then, I can multiply those two. So I'm going to go cosine of theta plus a sine times sine is a sine squared of theta over cosine. Now it's really important that you put the square here. I'll show you. Super important that you put the sine, the square. The square here goes here, not here. Tell me why it wouldn't go here. Go ahead, Evan. You don't want to square the angle, do you? What this really means is sine times sine. You guys agree? It's not theta times theta. So you have to put it here so you're not confused that you're squaring the angle. Does that make sense? Okay. Now, I got a fraction. So whenever I add fractions, I get a common denominator, right? So let's see. If I multiply this by cosine of a cosine, I get a common denominator. Okay, so cosine over cosine, right? That's going to give me, let's see, a cosine squared theta plus a sine squared theta over cosine theta. Okay, so here's what I did. I've got my common denominator, right? Which is cosine. Cosine times cosine is cosine squared. Now, if I've got the squareds, remember I told you where we're going to look. If I've got square terms, I'm going to look. My Pythagorean identity, okay? So I've got cosine squared plus sine squared. Cosine squared plus sine squared is what? 1. So the top, or the numerator, just becomes 1 over cosine theta. Now, that's an identity too, right? What's 1 over cosine? Look at my little notes. Yeah, 1 over cosine is secant, and that is got to be the simplest form that can go. How's that? Okay, all right, not too bad. Okay, example 2 is a little bit easier. It really is. Example 2 is, you guys okay with that? I like them. Sorry, I really like doing these because it's like a little puzzle for me. Okay, example 2 is easier. In fact, we did example 2, didn't we? But let's do it again. So again, when you try and change everything to sines and cosines, that's the trick. Change everything to sines and cosines. It's easier. So what do you know about tangent? Sine of cosine, right? What about cosecant? What's cosecant? Take a look at your notes. What's cosecant equal to? 1 over sine. Okay, hopefully you see something. Right? Cancel the sines. And I'm left with 1 over cosine. But 1 over cosine is secant. Yeah, I like these. Okay, so I shift it up when you're ready. Not too bad. That was pretty easy. Thumbs up. Okay. Example 3. Now, before I do example 3, a little bit of side work. If I had x cubed plus y squared x, just hypothetically, if I had an algebra problem, I could common factor, right? I could common factor out of x, right? So I would take out an x. I'd have an x squared plus a y squared, right? So if I look at example 3, let's common factor out a cosine, right? So if I common factor out a cosine of theta, I'll be left with a cosine squared theta plus a sine squared theta. Okay, now remember, when you see the squares, look at your Pythagorean identities. Okay, so cosine, sine, sine squared, cosine squared, sine squared plus cosine squared is 1, right? So this becomes 1. So I've got cosine theta times 1, which is cosine, right? Just cosine theta. All right? You still with me? Okay, good. You might even think this is easier than the stuff we just got done doing. Good, I like to hear that. That's cool. I like this stuff. Okay, turn the page. Am I doing good? Okay. Now, example 4. All right. Let's change things into sines and cosines, okay? So, let's rewrite this as a 1 over cosine minus a cosine all over a sine. Ugh, I got a fraction within a fraction, but it's going to get better. It will. Okay, so let's look at just the top part. Okay, let's just look at the top part. So I got a fraction minus a fraction. Let's get a common denominator. Okay. So if I want to get a common denominator, let's multiply this one by cosine of cosine. Right? Cosine over cosine. So let's multiply this second fraction by cosine theta over cosine theta. How's that going to help? Well, I don't know. Let's check it out, okay? So I'd have a 1 minus cosine squared theta over cosine theta all over sine theta. Okay? So hold on. I'll wait for you. Okay? I'll wait for you. Okay? So here's my common denominator, cosine, right there, okay? Here's my common denominator, cosine. And I get a 1 minus the cosine squared, right? And that's still over my sine squared, okay? Looks bad, doesn't it? But I think there's an identity. I got a squared, right? So I look for my squareds. I think I got an identity. 1 minus cosine squared is sine squared, right? So this 1 minus cosine squared is a sine squared. Okay, so I'm going to write that as a sine squared theta over a cosine, just plain old cosine theta, all over a sine theta, okay? Now I got a fraction within a fraction, but what I want to do is invert and multiply, because when you divide two fractions, and I made it into a fraction because I want to do that old trick from 6th grade, when you divide fractions, you invert and multiply, right? So I'm going to rewrite this as a sine squared theta over cosine theta times, right? Times, invert multiply, 1 over sine theta. Okay, do you see anything? This sine will cancel one of these, right? All right, I'm going to bring it up here. So what am I left with? I'm left with a sine over a cosine, but there's a better way to write that. Isn't there a better way to write sine over cosine? Tangent. Cool. Yeah, like, yeah, right, huh? Cool. I like these. Patrice's like, yeah, sure, Mr. Davies. Okay. All right, you guys ready to slide it for the next one? Last one. Okay. I got a fraction. I need a common denominator, right? So here's how I do common denominators. What does this fraction have? This one needs. This one needs a what? A cosine. What does this fraction need for a common denominator? A 1 plus sine. To make a common denominator, you have to make them the same. So I'll multiply this fraction by a cosine over a cosine, so that's my common denominator. And I'll multiply this fraction by a 1 plus sine over a 1 plus sine. Okay, now let's see what I have. So my common denominator is going to be my 1 plus sine theta cosine theta, okay? That's my common denominator. Now I'm going to FOIL this first one. I'm going to go this times this, this times this, this times this, this times this, okay? Are you ready for that? I'm going to FOIL. Am I going too fast? Slow me down if I get going too fast. So I'm going to FOIL. 1 times 1 is 1. 1 plus sine of theta is a 1 sine theta. Sine times 1, sine theta times 1 is a 1 sine theta. And sine times sine is a positive sine squared theta. Plus a cosine squared theta. All right. Looks worse, doesn't it? Looks horrible. But what do these two make? Take a look. What do these two make? What is sine squared plus cosine? That equals 1. Okay. 1 plus 1 is, oh man, okay, this does equal 1. Celeste, you're way ahead of me. I like that. So 1 plus 1 is 2, right? So let's see what we got. So 1 plus 1 is 2 plus, what's 1 sine plus 1 sine? 2 sine over 1 plus sine theta cosine theta. Okay, how am I doing? Does anybody see anything?
Can't you cancel out the signs?
No, not yet. Anybody see anything? What do they have in common? On the top, on the numerator, do they have anything in common? Don't they have a 2 in common? What if I factored out, common factored out is 2. If I took out a 2, what's going to be left over? What's going to be over? Oh, 1 plus sine. Oh, yeah. How's that going to help? See how I like these. Now what can I do? Now comes the fun part, right? 1 plus sine cancels 1 plus sine. Now you're left with 2 over cosine theta, right? But cosine is secant, so I get an answer of 2 secant theta. So before I start the recording, this is a great illustration of something that starts out pretty big and comes down to something pretty small. These are the same, really. This and this are the same. This is a lot nicer answer, isn't it? Okay. All right, trig identities. Woohoo! So, should we do our homework together?